Hi everyone, in today's lesson I'm going to introduce the definition of a matrix and how we can use matrices to solve systems of equations by Gauss elimination. A matrix is an arrangement of numbers into rows and columns. Matrices are primarily used to solve systems of linear equations. So let's take a look at what the matrices look like. Usually there are just numbers going down each column and numbers going down across each row. And we say that an m by n matrix has m rows and n columns and is said to have an order of mn, or m by n. So let's just get our definitions down. So it says, example number 1, determine the order of each matrix. So how many rows and how many columns do we have here? We only have one row and one column, so we would say that this matrix has an order of 1 by 1. Okay, now how many columns do we have here? 1, 2, 3, 4. And how many rows do we have? One row. So therefore we would say this matrix is a 1 by 4. One row by 4 columns. Alright, why don't you try examples 3 and 4 and hit resume when you're ready for the answers. Okay, so the third one, you should have 2 rows by 2 columns. So this is a 2 by 2 matrix. And the next one, you should have had 3 rows and 2 columns. So this has an order of a 3 by 2. Okay, let's move on to more definitions. A matrix that is derived from a system of linear equations is called an augmented matrix of the system. A matrix that is derived from a system of linear equations without the constant terms is called a coefficient matrix of the system. So let's just look. Here's a system of equations in 3 variables, x, y, and z. This would be the augmented matrix. Basically what happens is it's just the coefficients. So x has a coefficient of 1, y has a coefficient of -4, z has a coefficient of 3, and 5 is what it's equal to. So we take x, y, z, the coefficients, -1, 3, -1. And then here, this bottom row is very special because there's an x term, which is 2, but you see how there's a y term missing? We would just put a 0 because there is 0 y terms and a -4 for the z. Now sometimes, or most of the time, you will see an augmented matrix have either a dotted line or a solid line through this part right here, basically where the constants start, just to show that it's the equal sign down the row. Okay? And a coefficient matrix is basically everything but this last row, everything but what it's equal to. So I'd like you to take this system of equations here, and I'd like you to draw me an augmented matrix and a coefficient matrix, and then hit resume when you're ready to see the answer. Okay, so for the augmented matrix, you should have put 1, 3, 0, 9. There's no x term, so 0, -1, 4, -2, 1, 0, -5, and 0. And the coefficient matrix was everything but that last column. Okay, those are your 2 answers. Alright, now let's move on to the next page and see how this applies to solving systems. Okay, so solving a system of equations using matrices and Gauss elimination and back substitution. This is just a refresher of what those elementary row operations are. You can interchange 2 equations, multiply one of the equations by a non-zero constant. You can add a multiple of one equation to another equation to replace the second equation. So let's look. I want to solve this system of equations using matrices. So the first thing that we need to do is transform this system into an augmented matrix. So let's do that. So I'm going to take all of the coefficients. So we have 1, -2, 3, and 9. -1, 3, 1, and -2. 2, -5, 5, and 17. So the goal with solving matrices, just like we did with Gauss elimination, was we want to get this main diagonal here to all have 1s. And everything below it, all of these values down here, need to have 0s. So we already see that the first term on the diagonal is a 1. So I don't need to change the top equation. So I'm just going to start by writing the coefficients, 1, -2, 3, and 9. That I don't have to replace. And I actually don't even need to replace the third line, so 2, -5, 5, and 17. So what I really want to do is change this second line so that this first coefficient has a 0. So the only way that I know how to do that is, I think if I add the first equation to the second equation, these ones will cancel. And remember, when we add one row to another row, the sum replaces the second equation. So we're going to call this row 1, we're going to call this row 2, and we're going to call this row 3. So what I want to do is add row 1 plus row 2. That's my first step. Remembering, when I add them together, the second equation gets changed. So I'm going to do that work below here on the side, and I'll do it in a different color. So I'm going to add 1, -2, 3, and 9. I'm going to add that to -1, 3, 1, and -2. So when I add these together, those cancel. Then I have -2 plus 3, which is 1. So I can put that there. Oops, excuse me. It's actually going to go here because the first canceled to 0. So we've got 0. Then we have 1. And now 3 plus 1 is 4. And then 9 plus -2 is 7. So now I've got this term here, now is a 0, so I'm good now. So now I got to work on this term here, and I want to see that that becomes a 0. So how am I going to get this 2 to be a 0? Well, I could take this first row, and I can multiply it by -2. So what we're going to do is we're going to take -2 times the first, so -2 times row 1, and I want to add that to the third equation, to row 3. So if I do that, then I'm going to replace the third equation because that's the second equation in the sum. So we're keeping the first, that's not going to change. We're going to keep the second equation, that's not going to change. And we want to, like I said, we want to do -2 times the first and add it to the third so that I could have a new third equation. So I'm going to do that work down here again. So I'm going to do -2 times the first row. So the first row is this, and I'm going to multiply each of them by -2. So that's -2, +4, -6, and -18. And I want to add that to the third equation so that I can replace it. So here's my third equation. So I'm going to add that to 2, -5, 5, and 17. So if I add them, these cancel to 0. Then I have 4 plus -5, which is a -1. And then I have -6 plus 5, which is also a -1. And then I have -18 plus 17, which is also a -1. So now I've got this third equation to be a 0. So I'm good. Now I have 1, see, 1, 0, 0. Now I need to get this term to be, this 3 needed to be a 1, and I think I did that through something, through other terms. So this is a 1. So now my goal is to make this a 0. The only way to make this a 0 is if I added the second and the third equation together. So that's my next step. Add the second and the third equation. So I'm going to add row 2 plus row 3 to replace the third. So we're going to keep the first equation. We're going to keep the second equation. And now we're going to add the second and the third together to replace the third equation. So here's my second and here's my third. So I'm going to do the work over here. My second is 0, 1, 4, 7. My third is 0, negative 1, negative 1, negative 1. So these add together is 0. Negative 1 plus negative 1 is also 0. 4 plus negative 1 is 3. And then 7 minus 1 is 6. So I'm almost there now. I've gotten now 1, 0, 0. Now I have a 1 and a 0. Now the last thing is that this 3 needs to turn into a 1. So the only way I need to do that is by multiplying this equation by 1/3. So we can do that. So I have 0, 0, 3, 6, and I'm going to multiply that by 1/3. So I have a 0, 0, 1, 2. That is what's going to replace my third equation. So I have a new matrix, 1, negative 2, 3, and 9, 0, 1, 4, 7, 0, 0, 3, 6. Oops, excuse me, not 3, I just replaced it. 0, 0, 1, 2 from up here. So now I have my main diagonal being 1s. 1, 1, 1. Everything else below it are 0s. So what this implies is that this is my z value. If I have a 1 here, that means z equals 2. So those are now my coefficients, what I have left of my system. So I have, if I'm reading from up here, I have 1x minus 2y. So I'm going to write that here. 1x minus 2y plus 3z equals 9. Now I have no, on my next row, I have no x's, but I have a y. So I can put y plus 4z equals 7. And then my last term is that z is equal to 2. So now I can use back substitution to solve. So now that I have z, I can plug it into here to find the second equation to find y. So I have y is equal to negative 1, and then I can plug them both into the top equation to find x. So I've got x plus 2 plus 6 equals 9, x plus 8 equals 9, so x is equal to 1. So my solution is x is equal to 1, y is equal to negative 1, and z is equal to 2. That is my final answer. So just to recap, I used matrices, just using the coefficients, to get this system into Gauss form, meaning the staircase method. So x, y, and z, all of them have 1s, and then I have 0s across the board, and then I use back substitution to finish the answer. Alright, if you have any questions, jot them down, and we'll see you tomorrow in class.